The only people who may not benefit from that are the grid operators or the electricity providers. But I think that's a fair deal.
Today, we'll talk about VIPV, Vehicle Integrated Photovoltaic. So think of a car with a PV mounted on its rooftop. If you do that, to be quite frank, there's not too many cars out there that come to my mind. At least I have not yet seen a BMW or a Mercedes-Benz with a PV integrated in its rooftop. The only thing that comes to my mind is, for example, the Lightyear One, a car produced by a startup that has a PV on its rooftop and all around the body and is able to drive almost charging station independently. Also, thanks to being very energy efficient. However, at the mass market, I think it's mainly prototypes that never really make it to production. Nevertheless, there is validity to the concept, which you can see by the fact that Fraunhofer, Germany's most important research institute, dedicates a whole team to researching this topic specifically, because it does not only stop at cars. You can also think of trains and ships and airplanes, buses and trucks. And depending on which use case you look at there, the PV has to cover very different demands. It has to be very aesthetic when it's mounted on a consumer product, such as a car. It has to be very sturdy on an ocean liner, on a cargo ship. And it has to be extra lightweight if, for example, you integrate it into an airplane, a truck or a bus, as not to restrict the payload. So there are a lot of things to research, and there are a lot of interesting things to learn today. Welcome to the Smartery Podcast, a podcast for and with the creators of the new energy world. A world in which energy will be renewable, decentralized and digital, bringing together electricity, heat and mobility. Let us show you how we will get there and who will get us there. My guest today is Martin Heinrich. He's the project manager at Vehicle Integrated Photovoltaics at Fraunhofer ISE, so the Institute for Solar Energy Systems. He also is actually the chairman of the PV in Motion conference. Welcome, Martin.
Hello, everyone.
So, Martin, you're actually the chairman of the full conference, so it really is a thing.
Yes, definitely. We not only see that the solar roof will support, for example, air conditioning in the vehicle, but it will also help to achieve a higher range of the vehicle and even reduce the charging needs of the vehicle throughout the year. And this is especially true for trucks and larger vehicles.
Just tell us a little bit more. What can we expect from these kind of photovoltaic modules in the future?
Yes, for vehicles, we can equip not only the roof of the vehicle, but also the sides or the transparent vehicle body parts like the windows. And with this technology, we can achieve a much larger range extension, for example, for cars. For cars, looking at cars especially, we can equip with modern technology 30% efficient solar cells and achieve a range of roughly 15,000 kilometers every year for those vehicles. And this meaning 15,000 kilometers is also the average driving distance of a vehicle throughout the year. And therefore, we achieve calculatively independence of the charging needs of a vehicle. I say calculatively because this means since in Europe you also have winter, and in winter we have less sun received on the vehicle, so in winter there will still be charging needs. But looking at the summer times, we will probably have even more charge from the solar body than needed for the vehicle to drive.
What kind of cars will we talk about that there? Because obviously that's fantastic. That's almost a charging station independence you could reach when the vehicle is covered in solar panels, so to say. But are we talking about a specifically produced EV like a Lightyear One that is like a super high efficient electric car? Or are we actually talking about your standard BMW X6 SUV?
Yes, in this case, we also assume like an optimized vehicle for solar, of course. But thinking about like a standard vehicle, we can also achieve a significant contribution by solar for the extension of the driving needs. For example, on a standard regular vehicle, just using the solar roof, we can extend the range by 2,000 kilometers per year.
Right, and that would be around about 10%, my own calculation.
Yes.
It's an exciting technology. 2 quick questions. How far off are we from this being ready for mass production? And which kind of manufacturers do you think would pick up on this technology? Do you really think that, for example, VW or BMW or Mercedes would pick up on these technologies? Or is it something for little startups that are working on their ultra-efficient vehicles?
So we do currently see startups pushing that technology really forward. But we also do see that the more conservative manufacturers, like for example Hyundai, they are also pushing that technology into the market. There is the Hyundai Sonata, which is currently offered in the US and Korea, which has a solar roof. And there's also the Hyundai Ioniq, which will be offered in Europe with a solar roof on the vehicle. So there's quite an interest in the car manufacturer scene. And we also see that other car manufacturers are quite interested in that technology.
So actually there are some cars out there already who make use of this technology. In your opinion, what are the great advantages of really carrying your PV with you as a car user, so to say? And what is the technical potential of it? But before we hear that answer, a quick shout out to our partner Connexio PSE. Connexio PSE organizes renowned international scientific and practical business conferences focused on renewable energies, energy balance transformation, and the efficient use of resources. Their events bring together minds that are changing the energy world with forward-thinking technologies, promote knowledge exchange, and provide a global stage for innovation.
Yes, so we already discussed the main advantage that we can extend the driving range or the yearly kilometers, and we have reduced charging needs from the grid. And another aspect, we can also increase the comfort of the user by using the solar energy to cool down the vehicle while it's parked. So when you enter the vehicle, you have a cooled down vehicle and not a very high temperature within the car. And then there are also more other advanced aspects which benefit us as a community as a whole. For example, that we don't need to have as much charging station or as much charging needs from the grid, which will help to reduce the load on the grid overall.
So from all the things you mentioned, actually, I personally really like the cooling down the vehicle while it's parked, because as if I use an electric vehicle, I always feel bad if I turn on the air conditioning, because I'm like, oh, I'm wasting so much energy in this battery. So in that regard, I could really have a good conscience and just enter a vehicle that is already cooled down to a pleasant 18 degrees, for example, during summer. That's a wonderful thought. So in your research, what are the biggest difficulties you run into, and what are the biggest challenges that the manufacturers still need to overcome?
Yeah, so at first there's always a bit this afraidness of new technology. Yeah, so the vehicle manufacturers, they are quite familiar with the standards, for example, glass roofs. But here in this case, we have electricity from the roof. So they are quite afraid of implementing this new technology. So we need to establish an awareness and show them that the potential would be great to use this technology. And then the second thing is, of course, safety is very important. And just imagine you have electricity above your head. And we definitely have to take care about that and need to be very, very sure that there will be no hazards involved by that, even when the vehicle is crashed. But this has been already solved, for example, for retractable roofs, which also use electricity above your head. And then the next aspect is also the making usage of the electricity in the vehicle to the right time. Since your vehicle is, for example, parked for a long time in the sun, and during that time your battery is charged, and there needs to be an intelligent charging mechanism which allows to get this free energy also being used in the vehicle instead of the energy which needs to be charged from the grid. So these are, I think, the main 2 aspects which need to be addressed by this technology.
I guess that's something that will be solved generally also with the whole vehicle to grid issue. I guess on the long run, that does not seem to be such a big issue because that's being researched already. And am I right to assume that even if, for example, I already arrive with a full battery, I would even be able to feed that energy into the grid?
Yes, such technologies are actually currently researched also by, for example, Sono Motors and Lightyear, and also more conventional vehicle manufacturers.
And that to me also sounds like it actually is cost efficient, because for me as a vehicle producer, if I think I would produce a standard roof, that is already cost efficient as can be, and I just ask people to plug in their cars into the plug because it's much easier than like install a solar rooftop. But nevertheless, it is cost efficient to do that.
Yes, definitely. And it's even cost efficient for us as end users of the vehicle, because we receive energy from our roof and we don't have to charge it and pay for that. And for the vehicle manufacturer itself, it's also more beneficial, since he can sell the vehicle or this option of a solar roof for a bit higher price. The only people who may not benefit from that are the grid operators or the electricity providers. But I think that's a fair deal.
I think so too. I think that's something we can handle as a population in general. Just a wonderful thought. If I think of Berlin where I live and all these cars covering too much urban space already, actually being productive while they spend their 23 hours per day just standing around idly, a wonderful thought. We've talked a lot about cars now. So what other use cases do you see there? Is it really viable and productive on a truck as well? There's a lot more surface, but also a lot more power needed. Is it really suitable for airplanes? What other interesting use cases do you think are relevant?
Yes, so moving forward from cars, there's of course the trucks, which are very, very interesting for solar integration. Since we have a large roof surface, and therefore we can also extract even more energy from the roof of the truck than from a car. And this makes it even more usable for the end user, for the operators of the vehicle, since you will get more mileage throughout the year. And these are actually really tangible costs you can calculate for fleet operators. And there are, for example, other vehicles like the camper or boats, which use solar for a long time already to be more autonomous and self-sustained. Moving forward, there are also airplanes or drones, which can extend their range with integrated solar cells, lightweight solar cells, to be able to fly farther.
So actually, just that you mentioned that fleet operators might be interested in it, a sign for that technology actually being cost effective, because if there is something that fleet operators are really keen on, it's optimizing costs. So that's a great takeaway already. Specifically, that industry should be very keen on a fast adoption. So are they already working on it? How far are we there? How far is the trucks industry in integrating these solutions, and what are the problems?
So there are already first truck manufacturers which are looking at this technology. However, the trucks which can benefit from this technology most are electric trucks. And we don't have that many electric trucks on the road. Of course, hydrogen trucks will also benefit, but we also don't have a lot of hydrogen trucks on the road. So the next truck technology, which could be potentially benefit from that, are cooling units, like refrigerating trucks. And those trucks, we are actually also currently working on to implement this technology on refrigerating trucks and refrigerating units to cool down the load more efficiently and with solar technology.
That makes perfect sense. You've mentioned quite a lot of interesting use cases already. Are there some regulatory issues that need to be addressed, or is it a technology that you can just roll out freely?
I think to help the technology to be more implemented or faster implemented, there can be some regulatory changes. For example, currently electric vehicles have zero emission, but using a solar roof may even lower the emission of an electric vehicle, since we don't have to use the electricity from the grid, which emits some CO2 into the environment. And with that, like a regulation that solar roof will have negative influence on the CO2 consumption, that could help to extend that technology into vehicles. Another regulation I can think of is to require trucks to have less CO2 emission as they currently have, and to be more strict on the CO2 emissions of trucks, and really to force operators of those vehicles to implement new technologies.
In the beginning, I mentioned that you are chairman of the PV in Motion conference, which is, at the moment at least, a one-of-a-kind conference, because it is the biggest scientific conference for the PV in Motion community. So what can they expect from the conference, and what's the current focus this year?
Yes, so at the conference, we will bring together people from research and industry to talk together about this new technology for the research industry. And here we will have quite a lot of insights from the researchers on the actual potential throughout the world, and not only in Europe, but also in, for example, Japan or Australia. And another aspect is that we are not only looking at the potential of the technologies, but also how to implement that. And we also have quite some interesting presentations from the industry about their lessons learned, since some industries have been working on this topic for more than 30 years. So there's quite an experience in that technology already. And I'm very looking forward to the new insights which we will see from the other researchers in the world.
And just as a joker question at the end, to put it in perspective to other exotic PV use cases we have out there, because we already had a guest actually from Fraunhofer on agri-PV, we had a guest on floating PV, now we have vehicle integrated PV. If you look at these three, how would you position vehicle integrated PV in its relevance?
So vehicle integrated PV may not help a lot to reduce the electricity CO2 generation, but it will help in the vehicle industry to reduce the CO2 emission from vehicles. And I think that's a completely different aspect than the other technologies describe or look at. And I think that's very important, not only to reduce the CO2 emission from the grid itself, but also from the vehicles directly.
Wonderful. Thank you so much for joining us today, Martin. As usually, in the end, I will try myself at a wrap-up of all the takeaways we had so far. So first thing I learned, actually, it's already being used in some cars out there. At the forefront are, as usual, some startups who actually already build vehicles where you have the PV integrated into the whole body of the car, not only on the top, but on the sides. And if you have a very energy efficient vehicle, not an SUV, actually you can be charging station independent, in my own wording. On the regulatory terms, there's nothing that stops this technology. The only thing that would boost it more is if we would have tighter regulations on the CO2 emissions allowed per vehicle, or also for fleet operators. So I guess the big wish is just for the legislators to make tighter rules and even harder or harsher rules for fleet operators or car manufacturers. And there's yet a lot to be discovered and to be researched, because I think you're still working on making them lighter, making them more durable, and on solving issues, as you said, as well, making them more safe to have in close vicinity to your head in a vehicle, for example. Thanks a lot for joining us today, Martin.
Thank you as well.
Stay tuned for more episodes of the SmarterE podcast. Detailed information and exciting presentations on vehicle integrated photovoltaics can be found from December 6th to 8th at the PV in Motion conference, the world's first scientific conference dedicated to vehicle integrated photovoltaics. All info online at pvinmotion-conference.com.